Okay, hopefully the mic was originally working through the deal. My other mic wasn't turned on for whatever reason. Okay, so here's what I want you to do. On your whiteboard, I want you to show me an equation you can use to predict its height in X number of days. I want you to show me an equation that you can use to represent its height in X number of days. I want to see if anybody gets this right. It's very similar to compounding quarterly or compounding monthly. Okay? That's a little bit different, though.
Wait, so X number, could you say that one more time?
I want you to come up with an equation that will yield 60% growth, but only after 7 days. So this one, now that I think about this is actually a little bit harder than I anticipated. Okay? So maybe we just need to go through this a little bit together. Okay? So my height, right now it's starting at 10, right? We'll use the whiteboards maybe a little bit later. What's my growth factor? What should I have here? I'm just going to leave it at 1.6, and you'll see why here in just a little bit. Okay? My exponent's going to be a little funky. Do I want to multiply by 1.6 right away? No. Just like when I was compounding quarterly, I didn't want to give it interest until a certain amount of time. So my exponent, this right here, let's go D for days. That's going to be wrong. Because that right there would show me that it's gonna get 60% bigger every day. Divide what by 7? Exactly. Exactly. Nice job. So that is an equation that will yield 60% growth finally after 7 days. Okay? So this is actually this conceptually is a little bit bigger jump than I thought, but nice job, Rollo. Okay? I'll say your name so those out in YouTube land know how awesome you are. Okay? So this is a pretty important idea, because if we have a percent growth and I want it to grow that much but only after a certain amount of time, that's a little deal we can use. Okay? So here's kind of my grand plan. Okay? I want to use that idea to solve number 38. Okay. The first sentence, boom. A particular plant has a doubling time of 12 days. Do you want it to double right away? No, you don't. You don't want it to double until 12 days. It's going to start at 46. You don't want it to double till 12 days. Okay? So what you're going to start with is this. 46 times what? 2. Finish it. What's my exponent going to be? Write it and show me. I want it to double every 12 days. Good. 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 Nice. Sweet. Sweet. So this is, so that would be x over 12. Okay? There's my formula that I could use. Hopefully you understand what's going on. The 46, I think, is pretty basic. That's the same thing as we've always talked about. But this idea of, if we had 5% growth or 10% growth, then you could come up with the factor inside pretty easily. But this one is just doubling. And I'm going to double that every 12 days. Do you understand why it's divided by 12? In 12 days, it'll double once. In 24 days, how much will it double? Twice. In 36 days, it'll double 3 times. So we will have allowed it to multiply by 2 3 times. 2 times 2 times 2. Okay? So then, now there's an equation that we could go ahead and plug in 20, plug in 65, and then, of course, we have their formula for x is going to be different. And I have no idea how they're doing that function, because I think they're teaching that. I think they've thrown this problem in the wrong section. Okay? Let's do a different one. Okay. What if I said, I'm going to have to, I thought this actually would work a little bit better. Now let's say if I've got something that has a half-life of, I don't know, 2,000 years. And right now there's 100 units. Write a function for me. There's 100 units. It's got a half. Do you understand what a half-life is? Okay, I'm seeing some blank faces, so let me go ahead and explain. A half-life is how much time until there's half of what you have now. Okay? It's usually used with radioactive isotopes, like carbon-14, to date things, okay? But you could kind of stretch this to think about like melting ice. The half-life of melting ice might be like, an hour. Okay? So in a half hour, it's not quite half of what it was before. It's not half of its existing weight until, later on. So try this one. Boom. 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 Nice. Nice. Good. Have you guys seen half-life or doubling time before?
Yeah. In biology?
In biology? Okay, great. Great. Okay, can I steal yours? No, yours, it's good.
Oh, okay.
It's good. So just realize that if we're doing a problem like this, there's an equation we can use. Okay? So nice job, Hunter. Okay? So why am I doing this? Starting off with 100, I'm going to have half as much as I did before, and it's only going to take 2,000 years until that exponent is finally 1. So here's what I want you to do with your phone, with your calculator. I don't care. Find out the amount left after 100 years. And then show me on your show me on your whiteboard. Okay, good. Good. Is that a percent?
Yeah.
Okay, so I was thinking maybe grams, but yeah, that's fine. No, you're fine. You're fine. You're fine. Okay. Should it be down to 50 yet? No, because 2,000 years hasn't passed. Okay? Good. Nice job. So in this case, after 100 years, what do you guys get? 96 point what? 96.5. Okay? How long is it going to take to get down to 25? You can do this one in your head. How long is it going to take to get down to 25? No? 4,000. Why 4,000? Exactly. So the first 2,000 years, it'll drop from 100 to 50. And another 2,000 years, it'll drop from 50 to 25. And then another 2,000 years, it'll drop from 25 to 12.5. Another 50 years, it'll drop from 12.5 to 6.25. Okay? So half-life is half of what's existing. So that will be good to go and work with those problems. Okay. So here's the deal. Now, good. Good, 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 good. Let's move on to a different idea. Kind of a different idea. Logs. Okay? I'm going to do a little pretest with your whiteboards, and you're going to show me what you know about logs. Okay? On your whiteboards, nothing verbal. Nothing verbal. Log base 5 of 25. What does it equal? Show me the number. Can't use your calculator. Can't use your calculator. Nope. Okay. So, this tells me what I need to know. Okay? Here's the thing. Whenever you're looking for a log, well, first of all, I'm going to tell you. No. Well, okay. Here's the deal. You're remembering a change of base formula, which is impressive in its own right. But what this shows me is you guys, your critical understanding of what a log really is asking for is missing. So I need you guys to understand this. This is what we're going to work on today. The log base 5 of 25 is 2. Why? No. Because the exponent to take 5 to the second gives me 25. So whenever we're finding a log, we are looking for the exponent that you raise the base to get that 25. Okay? So whenever you're finding a log, you're finding an exponent. So that's what a log is. A log is an exponent. That's all it is. That's all it is. If you're wanting a log, I want the exponent. Okay? Whiteboards, here we go. Show me that you understand this. Log base 2 of 8. Write it down. Good. Good. Good, good, good. Good. So now you have me convinced that that you now understand what a log is. Okay? It is 3. Okay? Let me challenge you just a little bit. Well, let's do a couple more. Log base. No, let's go. I'm using your pencil, so I might as well take advantage of this. Log base 5 of 1/5. Impress me. 5 to what power is giving me 1/5? Good, good. What exponent can I raise 1 to? No. Yes. Yes. Could we take the log of 1/5 and divide it by the log of 5? Yeah. Yes, it's -1. Why? Because 5 to the -1 power gives me 1/5. Okay. Now, I'm going to see if there's, well, let's do another one. Log base 6 of 1/36. Good. 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 Perfect. Nice job. If you don't know, here's what you do. You're saying that 6 to the -6. Okay? So if you're ever not quite sure, here's what you do. You write what this means. It's really, see, here's the deal. I'm not a learn this method. I'm learn how it all works together. Okay? If you're not sure what this is, that means that 6 to the x is equal to 136. Well, 136 is the same thing as 6 to the -2. So x has got to be -2. Okay? Now I'm going to go on to the next stage of evaluating what you guys know and don't know. Log of 100. Nope. Nope.
You had one? No. That's what I'm trying.
He wrote the same thing you did.
Oh, really?
Boom. Let me write something else that will make you guys go, oh, I see this.
Oh, yeah.
My base is 10. So 10 to what power gives you? 2. Yeah. So there's a couple things. That's what's called a common log. Your common log, base 10, the reason why they call it common log, that's one of the most common bases we're going to use is 10. Okay? So 10 to the second gives me 100. Likewise, if I said the log of 1/10, show me. Good. Good. -1. Okay? Because it's 10 to what power gives me -1. Okay? So you need to understand what a log really means. It is I want the exponent, so please tell me what the exponent would be to give me that. So now I'm going to do this. I want you to approximate log base 2 of 10. What would that be about, do you think? Write down an approximation. Oh, okay. Okay. Good. So you guys doing a nice job. It's got to be bigger than 3. Because 2 to the third gives me 8, so it's going to be a little bit bigger than 3. I don't know what it is. I can go ahead and find that real quick. I could take, like you guys know, I could take log of 10 divided by log of 2, 3.32. But what I was looking for was something bigger than 3. That tells me you understand what's going on. Okay? What about this? What if I say ln? Do you know what that is? It's natural log. Natural log, the base is e. We use that so much in figuring out how long would it take to grow at a certain rate. Okay? So the natural log of e, say of e to the 4th. Well, this is what we're asking. E raised to what power gives me e to the 4th? Yeah, it's 4. Good. Okay? So you got to understand that this is an exponent. It's asking for an exponent. It's the exponent. It's the exponent, which is up here. Okay? So here's what I'm going to have you guys do today, is I want to just nail that down to make sure that you have an increased retention of what a log really means and how to go back and forth. Pick up that worksheet that's up front on the stack of graph paper. And please, can you hand me one as well? Thank you. No. We will not need whiteboards anymore. Look at Eddie's being efficient. I'm going to get up. I might as well put this thing away as it is. Tomorrow, so you got today, and then you got one more assignment for the week, and then we're done. Why would that be? Oh, you guys do remember my policy. Dang it. I was going to try and sneak one by you guys. Okay. So what I want to do is just a couple things. Let's go down to the bottom. This is from a different textbook. I want to go ahead and just make sure you understand exactly what we're doing here. It says write each equation in exponential form. So what does this mean? What to the what equals what? 2 to the 4th equals 16. That's all at once. The next one, what to the what equals what? No. 3 to the negative third equals 1 over 27. You need to be able to go back and forth. So that's going from logs to exponential form. And if you're never quite sure, again, what is a log? What are we looking for? Exponent. So right here, eyes up here. So the log is equal to the exponent. So -3 is my exponent. 4, that's my exponent. When you're taking these back and forth. Love it. Okay. So the next one, number 19. Log base what? Log base 9 of 1/9 equals -1. Because a log is equal to my exponent. That's what a log is. Next one, log base 4 of 4096 equals 6. Okay. And these down bottom, these I'm not going to do a bunch for you. I'll go ahead and do the first column. What the heck? Log base 3 of 1/9. 3 raised to what power gives me 1/9? -2. Because I've got to divide by 3 twice. Next one, log base 27 of 3. Nope. 27 raised to what power? 1/3. Because I've got to take the third root. Got to take the third root to get 3. Yep. Log base 1/5 of 3125. I'll give you, well, I don't know. Well, I'm just going to have to play around. It's going to be negative, right? Because what is a negative exponent? It'll flip that 1/5, right? So we'll just have to play around. 5 raised to the 5th. Yeah. It's going to be -5. Okay? Before we do any work with properties of logs and graphing logs and this, that, and the other, first thing you need to know is what the heck a log is. Okay? So here's what we're going to do tonight. We're going to do this. All the ones from that section that I did not do for you, or that we didn't do together. Okay? Okay? And then we're going to do page 167, numbers 37, 39. Thank you for letting me use your book, even though we didn't use it as much as I thought. Personally, I really like logs, but man, you've got to understand what they mean instead of just going, let's do my calculator and we'll do this divided by this. Page 178, 1 through 11 odd. So again, what's a log? An exponent. If they're asking for a log, they're asking for an exponent. It's not some magical thing. They generated a function, so when they needed to, they could find exponents. I am going to shut this off. And wasn't it nice to have a day